Hello, I am Erdem Tiryaki, Deputy Manager in Talent Department at Yüksel Proje. I graduated from Istanbul Technical University in 2017 and I have been working in civil design for approximately 9 years. In recent years, while working on tunnel project, one fundamental issue became very clear. We are designing highly complex three-dimensional systems, yet we are still relying on workflows that are largely two-dimensional. This mismatch between the complexity of what we design and the tools and methods we use creates significant inefficiencies. It directly impacts project timelines, increases cost, and can negatively affect overall design quality and reliability. In many cases, engineers spend a considerable amount of time coordinating drawings, resolving inconsistencies, and repeating similar tasks instead of focusing on engineering decisions. This not only slows down the process but also increases the risk of errors and miscommunication between disciplines. Recognizing this gap is critical because it highlights the need for a more integrated, intelligent, and digital approach to engineering design. Tunnel design is not solid. Geometry changes along the alignment, geological conditions vary, and support systems must adapt continuously. However, in conventional workflows, each change requires rebuilding the model almost from the beginning. This leads to long design cycles, performance issues, and most importantly, inconsistencies between drawings and models. Especially in TBM segment design, even small geometric variation result in completely different elements requiring separate detailing process. To address this challenge, a different approach was needed, not just improving the workflow but redefining how tunnel geometry is created. Together with our team, we developed a parametric modeling approach specifically for TBM segment design. TBM tunnels may appear geometrically simply, but in reality each segment is unique due to the tapering and alignment conditions. Even small variations in curvature require different segment geometries. Instead of modeling each segment manually, we defined the entire system using a limited set of parameters such as diameter, segment width, taper, and ring configuration. Based on these inputs, the model automatically generates the full 3D geometry of TBM segments, including connection details and structural components. This approach transforms segment design from a repetitive manual task into a controlled and adaptable system. The impact of this transition was significant. Design process that previously required days or even weeks could now be completed in minutes. More importantly, the consistency between design elements improved and the risk of modeling error was reduced. Engineers gained the ability to test multiple scenarios, quickly evaluate alternatives, and make more informed decisions. The focus shifted from producing drawings to understanding and optimizing the system. This approach also brings broader impacts. By minimizing repetitive modeling tasks and eliminating unnecessary revisions, both time and material usage are optimized. This leads to more efficient resource management and directly supports more sustainable engineering practices. At the same time, reducing manual workload throughout the process significantly decreases labor requirements, which result in noticeable cost saving and faster project delivery. The integration of parametric design with advanced 3D modeling tools represents a major shift toward fully digital engineering workflows. This transition is not just technological but also methodological. With this approach, BIM models can be generated much faster and with greater consistency, enabling collaboration between different disciplines such as structural, architectural, and mechanical teams. From an engineering perspective, embedding design logic directly into the model increases both reliability and traceability. This structured and intelligent modeling approach reduces the likelihood of errors and simplifies revisions when project requirements evolve. As a result, engineers are no longer spending most of their time on repetitive tasks. Instead, they can focus on evaluating multiple design alternatives and improving overall project performance. This shift creates more opportunity to work on value engineering, where cost efficiency, constructability, and performance are optimized together. Ultimately, from a societal perspective, faster, more accurate, and more reliable design process contribute to delivering infrastructures that is safer, more resilient, and better aligned with long-term needs. Parametric modeling is not only a technical improvement, it represents a shift in how engineering knowledge is applied from manual processes to intelligent systems. This transition enables engineers to focus less on reputation and more on decision making and value creation. And this is where the future of infrastructure design is heading.